We have a circuit problem. This circuit problem is in series where they have a voltage drop across each one. It's probably different because I imagine that R1, R2, and R3 are slightly different. And it is also asking us to show that the combined resistances are, when they ask you to show this, they're probably wanting you to do it via Kirchhoff's, either first or second law. All right. In series, it is normally going to be the second law where the voltage has to be used up completely. All right. So I times R is equal to voltage. I'm hoping we all agree by just manipulating I is equal to V over R. You could do I times R is equal to voltage. Okay. So the I total times the resistance total would equal the voltage total. Hopefully we agree with that. That is the voltage total, which I'm going to write here, voltage total. If you add up all the individual voltages, you get the voltage total. So that is what I total times R1 plus I total times R2 plus I total times R3 would represent. And the reason that we write I total is because the current going in through this first resistor has to go through the second and third. There's no splitting because it's not parallel. And then all of the I totals just cancel, leaving you with resistance total is equal to R1 plus R2 plus R3, which is what they have there. It's a two-pointer. There are harder versions of this to prove the parallel resistors are equal to like 1 over and 1 over and 1 over. But that is it for that one. I am going to show the answer keys occasionally to these to make sure that what I present is also what they did, and it is voltage, voltage, voltage. Voltage is equal to IR. I times this, and then the divide by I, get that. I didn't necessarily write all the words down, but I was pretty close to that. Okay, we have a battery with an electromotive force of 8 volts, apparently a negligible internal resistance. It has a thermistor over here, that's the thermistor, but currently switch X is open, so thermistor do nothing. Resistor R1 has 6 kiloohms and 4 kiloohms for the R2. I'm going to flip over to see what we have to do. We need to find the potential difference or the voltage of R1. That is our first goal, to find the potential difference of R1 with switch X being open. Okay? If switch X is open, that means that the circuit is going to run through the 6 kiloohm resistor, then through the R2, and then just complete the circuit. And these would be in series. So when they're in series, you can do I is equal to V total divided by R total, which means the current would equal 8 volts divided by 4 plus 6, but it's kiloohms, so you could write times 10 to the third on the outside, or you could just recognize that that's 4,000 plus 6,000 ohms. So we have an incredibly tiny current here. Very, very tiny. It would be 8 divided by 4,000 plus 6,000, which is 0.0008 amps. That is the current. That is not the question. The question wanted to know what is the potential difference across R1. Let's double check that. What is the potential difference across R1? So how do we find the potential difference across R1? You could either use Kirchhoff's, or you could be like, well, R1 is 6,000 ohms. And the current is 0.008. Voltage is equal to resistance. Voltage divided by resistance is equal to current. So you do 0.008008 is equal to voltage divided by 6,000, and you multiply to get the voltage. So times 6,000, and you get 4.8 volts, which should make sense because the entire circuit is 8 volts. 6 is bigger than 4. Proportionally, you could have did 6/10 of 8 to get the same exact answer. 6/10 of 8 is 4.8 volts. For the next part, I'm pretty sure we're going to close switch X. And when we close switch X, let's see, it says switch X is now closed. The resistance in the thermistor is 12 kiloohms. calculate the current in the battery. Okay. So I think we're just going to have to do this old-fashioned style, because now that this is closed right here, and this is 12 kiloohms, we can find the total resistance and then just do voltage total divided by resistance total. The total resistance is going to be a little difficult to find. It is going to be 1 over 4,000 plus 1 over 12,000 for the parallel section. That's the parallel section. When you add those, that would be the resistance equivalent for the parallel section. So we do 1 over 4,000 plus 1 over 12,000 ends up equaling 0.00003. But remember, that is not what the resistance equivalent is. You have to do, if this is equal to 0.0003 repeat is equal to 1 over resistance equivalent, you have to end up doing 1 divided by that answer. And that equals 3,000 ohms as a resistance equivalent. That means that combining these gets 3,000 ohms, or 3 kiloohms, which means if we simplified the circuit, we'd have the 6 and then the 3 immediately afterwards. You got the 6 before it for the resistor 1, then the resistance equivalent for these two combined would be the 3 kiloohms, and then it finishes with the 8 volts. Now we can figure out the current, which is the actual question. What is the current going through the cell or through the battery or through the battery? So what is the current going through the battery? Our resistance total is 9,000. 8 volts divided by 9,000 would be equal to our current. So 8 divided by 9,000 ends up equaling a current of 0.0088 amps, 0.00088 amps. And I am curious what the sig figs are going to be, or if they represent that as in scientific notation. They did choose scientific notation. This would have to be moved over 1, 2, 3, 4 times, so this would be 8.8 times 10 to the negative 4th amps. Oh, it would round up, though. 8.9, the 8 repeated. So 8.9 times 10 negative 4th, let's make sure I put it on the actual block. 8.9 times 10 to the negative 4th amps. Okay. Let's see. Candidates need to ensure that they converted units to kiloohms to ohms. Some candidates attempted to use the formula calculating combined resistance. Blah, blah, blah. They do not tell me. I don't think you're going to get it wrong because it's still the correct amount of sig figs. The zeros before the 8s don't matter. Although there is an exception to that. If it was like nanometers, you're not going to want to write 0.000000. Like, that would be annoying. I think there's a way in your calculator to automatically make it be in terms of like scientific notation. Okay. I don't know why I didn't think of this before. I could get both of them on screen at the same time. Switch X in the circuit remains closed. The temperature of the thermistor decreases. If the temperature of the thermistor decreases, that means the resistance of that resistor goes down. If the resistance of this resistor goes down, that means that the resistance of this section will also go down. Okay? Unless you're adding an additional resistor in parallel, it will operate the way you think. Resistance go down, resistance go down. Okay? By reference to the current in the battery, state and explain any effect of the decrease in temperature on the power produced by the battery. Okay, now we got to deal with power too. That's annoying. So let's start with a formula. Power is equal to I times V. The battery will still have 8 volts. Because it was 8 volts before, and changing a resistor on the outside doesn't mean the battery's still not going to be able to produce 8 volts. And it's a 3-pointer, so this is probably necessary. We're going to look at their answer as well. The resistance of the thermistor will go down due to the temperature. So the resistance total will also go down. due to the fact that the resistance total goes down, they actually wanted us to reference the current somewhere. Reference to the current. So the current going through battery will increase. If the current increases but the voltage stays the same, power, therefore, will increase. You are not allowed to use symbols on the ACE exam for that. I would not be able to fit it all in if I didn't. And this is the longest explanation I've seen from a response, too. And we look at the answer, it's crazy. As the temperature decreases, the resistance in the thermistor increases. Did they say the temperature decreased? Oh, man. Well, we would have got it wrong. I'm changing the problem. The temperature increased, then we get it right. All right? Temperature, when the temperature increases, the resistance decreases. If temperature decreases, the resistance would increase, and then everything in our entire paragraph would be the opposite now. So we're just going to change the problem to say increase. So as the temperature decreases, the thermistor would increase in resistance. If the total resistance increases, then the current would also increase, because if we're not going with my answer, we're going with their answer now. So the official answer, if the thermistor actually decreased in temperature, then the current would decrease because resistance would increase. If resistance goes up, then current would go up. They're probably going to say, therefore, the power of the battery is proportional. Therefore, the power produced would be power produced by there is proportional to current. If the current goes down, then the power would go down. We said the current would go up. Therefore, the power would go up because I missed one word. It's amazing how one word changes everything. But other than that, we did okay. Questions with this one before I just close the video? Yippee.